Yesterday you yelled at me and you were trying to. Today.
Yell at you.
You probably have some idea. I know. No, I probably forgot to hit the button because she didn't tell me to. That's alright, guys. We forgive you.
Thanks for forgetting.
Jacob, we do. So, simplifying, we're going to divide out common factors. What are factors again?
Numbers that can be
Who helped her?
Like divided into the number that and it turns out even.
Okay.
numbers multiplied together to get the original number.
Right. Okay. So, how do we do this? Well, a couple different ways again. First, I want to get an example. So we get 72 over 120. So basically, we're asking ourselves right here, right now, what is the biggest number that I can take out of both 72 and 120? Well, one thing that we just talked about when we did the problem that Grace asked about on the board was that I can do it multiple times if I want to. So I'm just looking for common factors in this, and if I notice with these two numbers, they're both what?
Even.
They're both even. That means I can always divide by what?
2.
2. Now, how many of you like to do a problem more than once? Well, raise your hand because it's none of you.
Yeah.
Okay? Most of you have a hard time doing the problem one time, right? So doing it multiple times isn't the easiest for you. Okay? So, if you see this problem right here, you can always do 2 because both of them, the numbers are even, but you might have to do that problem 4 or 5 times. So, do you want to do it 4 or 5 times using 2 every time because it's kind of easy? Or do you want to try to put some work into it to find the biggest number? Or you just look at some of these, and as we get used to this more and more often, you're just going to look at the numbers and you're going to say, oh, well, definitely what else goes into those 2 numbers?
12.
12 does?
12.
Okay.
24.
24.
Yes.
120 divided by 24?
It's 5.
Oh, okay.
What is?
So, how did we know that?
Probably use his calculator.
He doesn't even have one.
How do we know that? How does he know that 24 worked?
Because I did the
Even.
greatest the factor tree.
Okay, so he did the first way that we can do this by prime factorization. What did that mean again?
You narrow down all the factors till they're all prime.
Yeah, prime factorization is doing the tree, right? So I take 172 and I do 120 and I start breaking them down. Okay, that's basically what I can do. Do we like that? Maybe so, maybe not. It works every single time, right? But it could be a lot of work if the numbers are really, really big. All right? So let's just do this one. What'd you do for 72?
12 and 6.
12 times 6. 12 goes to
6 and 2.
2 times 6. 6 goes to
3, 2.
6 goes to,
3, 2.
and then I'm going to list them all, right? Now again, you could use exponents, but we found out that that kind of confuses some of us. How about 120? 12 times 10? 10?
5, 2.
5 and 2.
12?
6 and 2.
Why do you guys always use the bigger one first?
I just used
It's weird. 6.
3, 2.
How about 2 times 3? Anyway. Then we have 2 times 2 times 2 times 3 times
5.
5. And then to do this one, we would just look between the 2 sets and what? Finds what's in common, right?
3 2s.
1, 2, 1, 2, another 2, another 2, another 2, another 2, and a 3. So then, between one or the other, don't do both. I'm going to take those and multiply them together. 2 times 2 times 2 times 3.
24.
24. And that's what he got, right? That was the biggest one. So, if you do this process right here, prime factorization, this number down here should be the biggest that you can take out of both of those. And so when I actually try to simplify with this number that I got from prime factorization, when I simplify and divide, that should be my answer in simplest or lowest terms. Okay, so again, when I'm asked to simplify, I'm taking this biggest factor and I'm dividing both the top and the bottom by that number. Okay? So, what's 72 divided by 24? 3. What's 120 divided by 24? And then if I look at my last fraction, there should not be anything in common between those two numbers, and that should be my answer. Okay? So, I can use prime factorization every single time. What's another way that I could do it? Number 2, I could just show all my factors. Okay? So again, showing all my factors for 72, I'm going to start, and some of the ladies figured this out yesterday. You got to show that 1 in 72 or 1 in whatever the number is a part of your answers. Okay? 2 times, does it work 2? Obviously, because it's even. 2 times,
36.
does 3 work? Add them up, right? So 9, so 3 works. 3 times
24.
4. 5,
No.
6,
Yes. No. 12.
and then I'm done, right?
Yeah.
How do I know I'm done?
Because they're close by.
They're really close together or they surpass each other, right? Alex forgot that and he's doing it 8,000 different ways on number 1 and number 2 yesterday. Okay? 120.
Whole factors.
Here we go. 1 times 120. 2 obviously works.
6.
3 obviously works. Why do I say obviously works?
Because of the
I think some of you are making this way too hard when you're thinking about division. Don't think about the whole number. Does 3 go into 12? If 3 goes into 12, it goes into 120, right? Yeah, you just add another 0, right? So, does 4 work? Yeah, because of the same thing that we just talked about, right? 5
Yeah.
has to work because it ends what?
A 0.
In 0. How many times does 5 go into 120?
24.
6?
Yes.
Obviously. 7?
No.
8?
No.
Yes.
Yeah.
Yeah, I can. Wait, but
15, right?
yeah.
9?
No.
10?
Yes.
Yeah.
12.
11?
No.
12.
Yes.
12, we're right back to the beginning, right? Okay, so why don't we like this part? Takes a long time and we can miss one, right? And if we miss that key one, then we miss, yeah, we messed up. But we can do this, right? And if we're going to do this, I recommend probably you got a calculator because you can go a little faster by punching all those things in the calculator. But then to find my answer, I'm going to go through all that, and again, I'm going to try to find the biggest one, and so I come out with 24. Okay, so I can do that with every single problem. Okay, what's number 3? Number 3 is pick the easiest factor. So again, the easiest factor for me for this problem would have been what again? 2, because they're both even, right? So I'm picking the easiest number that I definitely know. But, big star with that, if I pick the easiest, and this is probably the fastest way for me to do it, I probably have to do the problem more than once. And again, is doing the problem multiple times using 2 a lot easier than doing these 2 things. That's what you have to decide right now. But again, when you start doing this over and over again with the same numbers, just in different numbers or combinations, it's gonna get a lot easier for you. Because it's just gonna start clicking in your head. That makes sense? Okay? So, if I did this problem right here, by picking the easiest factor, again, whatever I pick, I'm gonna divide both the top and the bottom by that same number. So this is again kind of the problem that we looked at with Grace when she was undistributing, right? She did it one time, but she quit. You always have to go and keep going until you get to the simplest form. So, what's 72 divided by 2?
36.
What's 120 divided by 2?
60.
60. So again, I would then stop and I would look at this, and again, they're both even, so I could do 2's again, or I look at this one and maybe what pops into my head? 6, because that's a little bit easier and it's bigger. The bigger the numbers, the less time I'm going to have to do it. But I could do 2 again, but a lot of you said 6 at the same time, so let's do 6 for both of them. 36 divided by 6. 60 divided by 6. So again, now we did it 2 times, but are we done?
No.
No, because they're still both what? Even, so that tells me I can do it by,
2,
and we get,
3.
5.
which we had way back here, when somebody noticed that 24 was right away. Okay? But don't give him too much credit, he did all this work. Not that that was wrong.
I didn't do the bottom line, I didn't multiply that. I just saw 12.
Alright, so do you understand what we're saying when we're going to simplify today? Okay, so we're going to try to do this with all kinds of numbers or all kinds of variables also. But let's start with true fractions. When I say a true fraction, I mean just numbers. So, quick glance, biggest number I can take out of there? 5. Anybody see anything different? I don't think so, right? So, again, if you have to write it at the beginning, put what you're dividing by, because I got to divide both of those numbers by that. 25 divided by 5, 40 divided by 5.
8.
Last thing I look at, can I take anything else out? So that's my answer. So again, no offense, I'm probably going to do this the most times. Because I can always think about even numbers. Now the ones that, if they're both in 0, 5, I'm always going to use 5. You know, all those kind of divisibility rules that we talked about at the beginning of the chapter, I'm going to use those to try to make it go faster. These two things always work. There's just a lot more work, right? Okay? So totally up to you how you want to do it. What about this one?
You can't do that.
So, that's my answer. The problem is my answer again. Or you just say, can't simplify. All right? Or just write the answer down again. Okay? Not an error. No, it's not an error. All right, ginormous one. Try it on your own. 88 over 5,280. So when we take your calculator away, this one's even more difficult, right? So quick thought right away. What's your quick thought? Definitely could be both be divided by what? 2, because they're both even, right? Then you might say, well, I might want to take a chance. I definitely can't do the top by 10 though, right? Because it doesn't end in a 0. But what else is really obvious for 88? 8 maybe? Or 11? Or even 4? So maybe that's where I start with 5,280 if I don't want to try 2 right away and just keep doing 2, 2, 2 all the time. Maybe I take a chance and do it with one of those numbers. Or, again, I can come back and do one of these things. This one might be worthwhile doing these. Who knows? Go for it.
I think I have the answer. It's blurry. It's blurry.
How do we do? So again, look, I tried the 8th and the 11th like everybody kind of suggested, and then I jumped to 4. And 4 was my first one, and then I looked at it, and I got 11 out of 660. How do we do? Okay, so, okay with that? Those would be what I call true fractions, where it's just a number over a number. Now we're going to do, basically, terms. So when you do this, these are just going to include variables. Remember now, what does a variable with an exponent really mean? So, for example, what does m cubed really mean? M times as many times as the number is, right, in my exponent, times itself, okay? So, one thing that I could do with m cubed, instead of writing m cubed, like Caleb said, I could write it as m times n. Everybody agree with that?
Yep.
Okay, so when you have what I would call terms on both the top and the bottom, so we're going to simplify fractions involving terms. Number one, numbers are the same. We do the exact same thing that we just got done doing in the first, 3 or 4 examples. So we do the numbers exactly like it is. So you got to pick whichever version you like, and you do your numbers. So if I look at this, fastest number I can look at right away would be what? 5, right? Because they end in a 0 and a 5. So what's 20 divided by 5? 4. And what's 65 divided by 5? 13. Okay. So before I continue though, make sure that that's the smallest that I can go with my numbers. What do you think? Yeah, right? 4 divided by 13. Can't do anything else. If I would divide it, I'd get a decimal, and I can't take any numbers. You want to scoot over here so you can see a little farther? All right. So now with the variables, in a sense, I'm going to cross out the same amount on the top and the bottom. Sit in that desk behind Grace. Can you see from there?
Yeah.
Well, then sit in my chair. Pull it up. So this is where Caleb, if you wanted to write them all out and then cross out the same amount, or remember now, what's my exponent on just m? It's a 1, right? So it's saying I have 1 on the bottom of both the m and the n, correct? So if I'm going to cross out the same amounts, I can either write them all out, or I can just say, well, I'm going to take 1 from the bottom. That means I'm going to take 1 from the top. And so instead of m cubed, I would have what? M squared. Or I can write it out and I would just cross out one of those m's. So then, basically, wherever the bigger exponent is, that's where your answer should be involving the variable. So if the bigger variable with the exponent would be on the bottom, then your answer has to have a variable on the bottom. Does that make sense? Or vice versa. So in this one, the variable m cubed is bigger than m to the first, so my m's better end up on the top of my fraction. I can't just put them wherever I want. They have to go wherever the more we're at the beginning. That makes sense? Kind of a weird way of saying it. All right? So we have m squared on the top. Now, what about my ends? So again, I got 1 end on the bottom, I got 2 ends on the top. Or if you wanted to write them out, go ahead and write them out. But that's what n squared means, right? So I'm going to take all of my ends on the bottom, and I'm going to take one of my ends on the top, or turn this into n to the first. And so we end up with n to the first on the top. Now this is really important that you extend your fraction bar and make sure that it's on top, because sometimes when we write it like this, some people get confused where that n should be. Now, realistically, if you write it off to the side, the n is always on the top. But just be careful, if you somehow draw this line right here and your n ends up like this, we don't want the n on the bottom. Okay, so you gotta make sure that the n is definitely either way off to the side or on top. If it's off to the side, it still means that it's on top because this, remember, we can put anything over 1 and it's still that same thing.
Does it have to be into the first, or can it just be?
Can just be n. You don't ever have to put that one there. Okay? Questions there? So let's try some more. 18 a squared all over 16 a b. Try it out. So again, if you don't cross anything out, it stays where it is. So in this instance right here, because I don't cross out any b's, my b has to stay on the bottom. Okay? So the biggest number I can take out of both 18 and 16. 2. 18 divided by 16. Or sorry, 18 divided by 2. 16 divided by 2. 8. Okay? No big deal if the bigger number is on the top with the fraction, right? What kind of number is this?
Mixed. Improper.
Improper, right? Improper meaning the top number is bigger than the bottom number. Okay? Now we do our variables. What is my variable? Where is it? And how many do I have? A is where? On top. Just one A, right? And what else?
Be on the bottom.
B on the bottom, right? A cancels out one of these A's, and then the B's, there are no other B's, so my answer is 9A over 8B.
So we don't have to reduce. Oh, yeah.
Can't reduce anymore. That's as small as I can get. Everybody agree? 2A cubed, B to the 4th, all over 10, A to the 5th, B to the 4th. Remember now, we're dividing, we're not subtracting. So when I divide the same number, what do I end up with? I end up with 1, right? I don't end up canceling it entirely out. That's a big difference too. Everybody get an answer? Biggest number I can take out of both numbers?
2.
2. On the top, what's left for my number? 1. Do I need that 1 on top? Maybe, maybe not, but we'll put it there for right now. 10 divided by 2? 5. So we got 1/5. How many A's do I have left and where are they?
2.
Where? On the bottom, right? There's 3 on the top and 5 on the bottom. So 5's bigger, so it's got to have 2 on the bottom. I cancel out all 3 of these and take 2 or 3 away from the bottom. So I end up with A squared. What happens to my B's?
Cancel out.
They totally cancel each other out. So, do I need this 1 on there? Definitely, because that's the only thing that's left on the top. I can't have this, right? So I need that 1. If there's some other term up there, an A or a B in this situation, or any variable or a number, then I don't need that number 1, right? But because there isn't anything else up there, I have to have that 1. Make sense?
So if you have only variables, okay, so you have 1 still on the top,
And then you have variables along with it, you don't have to have a one.
Right. And then I never need a 1 on the bottom. If that's the only thing that's left in the bottom, I don't have to write down. Okay? Questions? Want to see any more examples?
One.
One more. All right. Let's go over here. (25) m squared. NP all over 65 m to the 5th p cubed. Now you probably got to go back to your seat. How do we do? Biggest number I can take out of both my numbers. 25 divided by 5. 65 divided by 5.
13.
Do we already have that one? Weird. How many m's and where are they? 3 m's at the bottom, right? There's 2 up here, and I take 2 from 5, so that's 3. N, there's only 1 n in the whole problem, so it's got to stay there. And how many p's and where?
2 p's on the bottom.
P squared on the bottom. And again, make sure that my fraction bar is over top of everything on here. Don't write this, right? Because now that p squared is off to the right, and it looks, you need to write down the assignment before you leave. Or it's on Infinite Campus and Canvas if you want to look there.